All right, in 3.2b, we're continuing with polynomials, and we're going to use what we learned with the leading coefficient test and multiplicity to help us to write and graph these equations. All right, so first of all, how do we write the equation? So let's say that they gave us these zeros, and we're asked to write the equation that gave us these zeros, okay? So basically, we're working backwards. So we're going to think backwards, okay? So if x was 0, x equals 0, then I know that there's just an x in the equation somewhere. And then the 7 had to come from a factor, like an x minus 7. Now, how do I know it's x minus 7? Because think, if it's x minus 7 equals 0, and I solve that, I get the positive 7. So what you're going to notice is that basically it switches the sign as it becomes a factor. This is what we call a factor, okay? So you got to make your factors, all right? So the 7 came from x minus 7. A 0 just comes from an x, so we're on our way. Now, I don't leave it like this. I'm going to go ahead and multiply it out. And that would give me x squared minus 7x. And there's my equation. Done. Now, let's try number 2. Okay, we're going to use what we learned about factors on example 1, do the same thing here. We're going to convert each of these to the factor that gave us that 0. So to get a positive 4, it came from a factor of x minus 4. To get a negative 3, it came from an x plus 3. To get a positive 3, it came from an x minus 3. And then to get a 0, I just had an x. Okay, so I'm just going to start by multiplying these guys out by 2. I'm going to do these two, and I'm going to multiply these two. So if I FOIL this first 2 out, I get x squared plus 3x minus 4x minus 12, which is x squared minus x minus 12. All right, so when I distribute the x over here, I have x squared minus 3x. All right, so I need to multiply these together, and the easiest way I know to do it is to build the 3 by 2 table, and it looks like this. Don't be afraid to take up some room doing it. And I have x squared minus 3x. All right, now we just multiply as if it was a regular box. So x squared times x squared is x to the 4th. Then I'll have x squared minus x is negative x cubed. Then x squared times negative 12 is negative 12x squared. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative x is positive 3x squared. And then negative 12 times negative 3x is a positive 36x. Now, you kind of know if you did it right if the diagonals are like terms, okay? So I'll put them in order, exponent order. Start with x to the 4th. So negative 3 minus 1 is negative 4x cubed. 3x squared minus 12x squared is negative 9x squared. And then plus 36x. All right, so look at that. We came up with a polynomial to the 4th power. Now, I don't think you're going to get anything higher than that. So that gives you an idea. So what do? You start by creating the factors and then multiplying the factors out. Now, another way you may be asked to write a polynomial is given this information. Find a polynomial function with the given zeros, multiplicities, and degrees. All right? So I'll show you what degrees means here in a second. So it's kind of the same idea of what we just did. You're going to create the factors that match these descriptions, okay? So f of x, if it has a 0 of negative 2, then it came from a factor that was an x plus 2. The multiplicity of 2 goes right there. It's a power. A 0 of negative 1 came from a factor of x plus 1 with a multiplicity of 1. Now, the degree part, that may be new to you, but all it means is that if you add the powers on the factors, 2 plus 1 gives me 3, then I have all my powers correct. Now, when I multiply these out, I'll have x plus 2 times x plus 2. That gives me x squared plus 4x plus 4. And then I got to multiply that by my x plus 1. So I have x cubed plus 4x squared plus 4x, and then x squared, 4x, and 4. So f of x equals x cubed plus 5x squared plus 8x plus 4. And again, once you multiply it out, you should see the degree. The highest power of exponent is your degree. So notice the 3 right there. We have met our degree criteria. So let's try this again with number 4. So I start by creating my factors. So if it's negative 4, it came from a factor with a plus 4. Multiplicity of 2. If it's positive 3, it came from a negative 3, x minus 3 with a multiplicity of 2. All right, so if I multiply these out, I get x plus 4 times x plus 4. If I multiply those, I get x squared plus 8x plus 16. This is x minus 3 times x minus 3. X squared minus 6x plus 9. So honestly, if it's like this, I think you can leave it in this function. It's going to be really nasty to build that box, but you can leave it this way. I'm totally fine with that. Now, check your degree. If you did multiply these out, you'd have x squared times x squared, which would give you an x to the 4th, which is the degree we wanted. You can look here at the factoring step and see that. If you take these exponents and add them, you get 4. And so our degree matches what the description was. So you can leave it like that, all right? Now, graphing. So here's what the graphing instructions will say. Sketch a graph with the given information. Number 1, apply the leading coefficient test. Find the real zeros. Plot a few additional points and draw the graph. All right, so here's how this will work. Start with that leading coefficient test that we talked about before. So we look at the highest power of x, and we notice that it's odd and it's positive. So do you remember that mimics the linear function? So the two ends are going to go like this. All right, so I need that information. Find the real zeros. So let's factor this. If I factor an x out, I'll have x squared minus 9. And that would give me x times x minus 3 and x plus 3. So my zeros will be x equals 0, x equals 3, and then this one gives me x equals negative 3. Great. So those are my zeros. Now, when you draw your graph, 1, 2, 3, you know you have a point at 0, or negative 3, sorry, 0, and at positive 3. Now, you can apply the leading coefficient test. Look, the ends over here, they go in opposite direction. It falls to the left, right? So take your furthest left 0 and draw your curve going down. And we said it rises to the right. Okay, so take the furthest right and curve it up. Remember, it's a continuous curve. Now, 3 says plot a few additional points. So like we could plot some points at like f of negative 2 and at f of positive 2, because we need something on the left and the right to connect our dots a little bit more. So at f of negative 2, I'm going to go back to my function. I'm going to do negative 2 cubed minus 9 times negative 2. That would be negative 8 plus 18 gives me a positive 10. So that means at negative 2, it's way up here at positive 10. It's a continuous line. Not perfect, but you get the idea. And then at positive 2, if I put a positive 2, 2 cubed minus 2, or 9 times positive 2, I get 8 minus 18. This gives me negative 10. So it's going to be way down here. So my curve's going to do this. All right, so this kind of gives me an idea of what it should look like. And then if you want, for now, you can use your calculator and graph it on a calculator and see if it looks like what it should. Now, in the test, you're going to have to do this without a calculator, but this is a time that you can build your confidence by checking yourself with the calculator. Let's try another one. All right, again, look at just the generic formula. Look at our leading coefficient. It's negative and it's even, right? So remember, what did a negative even graph kind of do? It falls. Falls left and it falls right. Right? That gives us an idea what the ends of our graph are going to do. Now, finding the zeros. The first thing I would do is get rid of this negative out here. Okay? And the easiest thing to do is take a negative out. That'll give me x to the fourth minus 9x squared plus 20. Now this trinomial here is factorable. And don't let the negative one throw you off. It's not going to change anything. We needed it to tell us the direction of our lines, but it's not going to help. It's not going to change our zeros. Now we can factor this. This would be x squared minus 4 and x squared minus 5, right? So we set each one equal to 0. Now the negative 1 is not equal to 0, so you can ignore that. So I'm going to take x squared minus 4 equal to 0. So x squared equals 4. Take the square root. You find that x is plus or minus 2. So I have a 0 where x is 2 and where it's negative 2. Right? And if I do this over here, solve, I get a 5, and I'm going to take the square root. So x is positive square root of 5, and I have an x at a negative square root of 5. Now, square root of 5 is somewhere between 2 and 3. Okay? Somewhere between 2 and 3. So let's see what happens here. If I have 1, 2, negative 2, negative 3, and 2 and 3. All right, so let's do this. We know all our multiplicities are 1s, so it's going to cross right through, real nice and easy. If you had a multiplicity of 2, you would know it would bounce, but these are just multiplicity of 1. So we know it crosses at negative 2. We know it crosses at positive 2. We know it crosses at negative square root of 5, 0, so that's somewhere in between, and at positive square root of 5. Let's remember our end behavior. They're going to fall on both sides. So I can go ahead and put that right there. Now, an additional point that I might encourage is right here where x is 0. What is that graph doing where x is 0? We need to know what's going on here. So let's put a 0 in there. So we'll have 0 to the 4th minus 9 times 0 squared minus 20. Well, that's a negative 20. It's way down here. So what does that tell me? If it's coming down, that means it can come up and connect. This had to reach way down, come up and connect, and then it's a continuous curve. All right, so you can see what the x to the 4th is doing. It's kind of like an M. This one happens to be going down because of the leading negative. All right, so graphing is a little tedious, but you can do it, I promise. We're going to practice this in class and see what questions you have.